Okay, so for these last couple examples, we're just going to work on finding a scale factor. So usually when you enlarge pictures or you change the size of pictures, you're dealing with scale factors. You're dealing with dilations. So in example 5, it says you are making your own photo stickers. Your photo is 4 inches by 4 inches. The image on the sticker is 1.1 by 1.1. What is the scale factor of your dilation? So we are going from the photo to the sticker. So this is going to be a reduction, okay? It's going to be a reduction. Meaning my scale factor is going to be between 0 and 1. It's going to be like 1/4 or whatever. So the scale factor of this dilation, I would write it like this. I would write, if I'm going from large to small, be 1.1 over 4. Now this is weird because I have a decimal inside of a fraction. So really you could use decimals, but sometimes decimals just get a little messy. If I did 11 or 1.1 divided by 4, it would be about 0.275, okay? Or this could be represented, if I multiplied both of these by 10, which sounds weird, 11 over 40. So either one. For me, knowing that that reduction is a decimal that ends, it's easier for me to do that math, okay, with a calculator. But if I get something like 2/3, I am not going to multiply by 0.66 because that little bit of a decimal place being off could cause the picture to be a little different than what I actually wanted. Would it be minor? Yes, but if we're talking about big scale things, a decimal here and there actually makes a big difference. So the idea is if I have a decimal that terminates, that's exact. If I have a decimal that repeats and I round it, that's not exact. And we're going to talk about that later on with accuracy and precision. So in example 6, finding the length of an image. So in this example, it says we're using a magnifying glass that shows the image of an object that is 6 times the object's actual size. So we're going to determine the length of the image of the spider seen through the magnifying glass. So what we have to know is, with our spider, okay, the spider itself is 1.5 centimeters long, okay, tip of the foot to tip of the foot. Now, we want to see what it would look like in the magnifying glass. So for me, to find that, this is an enlargement, right? The magnifying glass is going to enlarge the image of the spider. So 6 times its actual size, I would take its actual size, 1.5 times 6. So this 9 centimeters means the spider will appear 9 centimeters long in the magnifying glass. So essentially, you're always multiplying when you use a scale factor. But that scale factor, the difference between it being 6 or 1/6, an enlargement means I'm multiplying by 6. If this was a reduction, I would be multiplying by 1/6, okay? So another example of a dilation is literally when your eyes get dilated. It says an optometrist dilates the pupils of a patient's eyes to get a better look at the back of the eyes. A pupil dilates from 4.5 millimeters to 8 millimeters. What is the scale factor of this dilation? So in this, what we are doing, sorry, kind of skipped around there. What we are doing is we are actually enlarging, okay, what your apparent eye, the millimeters of your eyes really are. So I'm going to write that out. This is an enlargement because we're going from 4.5 to 8. So knowing that, I know that number, that scale factor, has to be bigger than 1. So the fraction I would actually write is 8 divided by 4.5. Now, 8 divided by 4.5, it's going to be 1.7 repeating, all right? That's not great for a scale factor. So it seems kind of weird to change a fraction to be a little bit different looking. But if you think about it, I want to write a fraction with no decimals in it. So I could, and I'll actually show this work, I could multiply both of these by 2 over 2, okay? So this becomes 16 over 9. This does not change the value of this fraction because I'm multiplying by 1. That doesn't change the value. I'm just writing this as a fraction with a whole number on the top and a whole number on the bottom. That's the only reason I did that. So it's 16 over 9. This gives me an exact scale factor. Writing 1.78 from rounding, I don't want to see that, okay? If we can get it as a fraction, let's try to get it as a fraction. If it's a decimal that terminates, that ends, fine to use, it's exact. But if we round, we're not getting exact values, okay? So I really meant for that last one to be guided practice, but I really wanted to show that. So for number 3, treat this as your guided practice and try this one on your own. Pause the video, work through it, and then wait for me, my solution to compare it to yours, all right? Okay, so this example is the flip side of example 6. We are looking at the spider through the magnifying glass, and it appears to be 12.6 centimeters. We want to find the actual length, so that basically flips our scale factor. It's the reciprocal of our scale factor, because if I were enlarging this, I'd multiply by 6. But the fact that I'm reducing it means I multiply by 1/6. So it's 1/6 the size, meaning that spider is actually 2.1 centimeters long or wide, or however we want to say it. But we've got to understand with scale factors, whether it's a reduction or an enlargement changes. It's kind of like thinking of dividing or multiplying. But I like to think of it always as multiplying and then understanding, am I multiplying by a number bigger than 1 or a number between 0 and 1? Multiplying by a number bigger than 1, greater than 1, results in an enlargement, makes our image bigger, all right? And a reduction makes that image smaller, so we'd be multiplying by a number between 0 and 1, okay? So this would be a good chance for you to do the next quizzes and then work through some of the practice, because we are just going to be doing lesson 4.5, then 4.6, and then you're going to take the final quiz for Unit 4 and then be moving on to Unit 5. So this lesson's a little bit bigger, but I like separating some of the coordinate geometry stuff with some of this more real-life enlargement reduction stuff. Okay, so you can move on to the next step in the lesson.